Okay, fill it in for me, guys. If we define f of x to be the hyperbola, right, 1 on x, then what's f dash going to be? What's the derivative going to be defined as by definition? First word I write? Limit. Yeah, it worked. Well done. The limit as h approaches 0
Because you want to find the secant
of, yeah, other way around, okay.
Wait, hang on.
Yeah. Oh, we're so close. What am I going to have on the numerator here? I want f of x plus h, right? F of x plus h is 1 on x plus h. Do you agree with that? That's me putting x plus h into f, right? And I'm going to take away, because I'm working out the rise here, 1 on x. Very good. That's f of x all over h. Okay? Now, before we were just dealing with powers of x, so it's pretty simple. All you need to do on the numerator was just expand the thing and it just magically simplified out. Okay? What are you going to do here? There's no expansions to do.
Times x plus h.
I'm going to, well, I've got a number of choices here, right? Essentially what I want is to put this into a form that's going to allow me to get rid of this, right? Allow me to get rid of this. So for instance,
Rationalize the
well, it's not irrational. We will get to that. Okay. What it is going to be is if I just add that fraction, that pair of fractions on the top. If I just add them, okay, then this is going to become x on x plus h, right? And this is going to be x plus h on x plus h. Do you agree with that? Just common denominator business. Is that okay? All over h. Okay. So now when I take the limit, what's happening up there? What's happening? I'm going to have x minus h on x plus h. Do you agree with that? That's that numerator. That's just the numerator. That's being divided by h. Is that okay? Just combine the fractions together. All right, now this is great. You see that? That's really good. Cancel, cancel. Right? So I've got, let's not skip anything here. Okay. I've got minus h on x plus h. Right? That's my numerator. All over h. Now my h's can go. Right? This is just like before. The x's did cancel all out once I add the two fractions. Okay. So I've got the limit as h approaches 0 of, what have I got? Minus 1 on x plus 8. And now I'm in a position where I can actually evaluate and see what happens when h really is 0. Okay? Which is minus 1 x, not x plus h, x plus 0. I've just ran out of space, but you can see what I get. Sure enough.
So I always get really confused when, you know when you have like 3 fractions on top of each other?
Yep.
How do you know the top 2 go together or if the bottom 2 go together?
Think about where you began. Right? So if you see this, if you see 3 on 4 on 5, if that's what you saw, you really can't know whether that's 3/4 divided by 5 or 3 divided by 4/5. And they're different, right? They're completely different. So what you have to think about, like this is bad. You should never ever see that in theory. I should know though, because I made this fraction on a fraction, right? I was the one who made it. I should know that I had fractions on the top to begin with, not fractions on the bottom, right? So that's why this fraction here, that's the first time it becomes one fraction, is that rather than this, x plus h. I should know it's that, not that, right?
But you know when they have those questions which is like 1 on 1 plus 1 on 1
Yeah, then in those cases, you kind of have to rely on the lines, which is not very good, but that's 3/4 on 5.
Oh, because the big line means that,
Yeah. It's a little bit, not exactly the same as using these.
Oh.
Right? When you've got nested fractions, just like when you've got nested brackets, you kind of have to look at that.
Okay. So always get them wrong.
If it makes you feel any better, you won't meet many of those. Some, but not many. Okay, so it worked. It worked.